For the serverless meetup in the Microsoft Reactor space. We're still kicking off. We'll probably be about 5 or 10 minutes away. But thanks for joining.
Alright guys, we're gonna kick off. Cool. I'll log into this one. Welcome everyone. Great turnout tonight. Thank you so much for coming along. My name is Peter Hansons. I'm one of the co-organisers for the Serverless Meetup. I also co-organise a conference that's coming to Sydney on August 27th called Serverless Days Sydney. We've got some pretty awesome speakers coming along, if I can come along, including our first speaker tonight, Geshan from The Iconic. We've got speakers like Ben Coey and Jeff Holland, who's the product manager for Azure Serverless, Azure Functions, and the rest. But yeah, so do encourage you to go check that out if you've got some time. Tickets are like $69. It's going to be an amazing conference. I'm very biased, of course, because I'm one of the co-organizers, and I think serverless is amazing. I do not know why this room isn't packed to the rafters, but that's just me. But awesome. I'll stop talking very shortly. Our first speaker tonight is Geshan Manandhar. Is that a good pronunciation? From The Iconic. He's going to take us through Google Cloud Run. He'll probably explain it much better than I do, but it's basically a serverless containers environment. So you can just put together a container, publish it, and it'll just kind of run without you really worrying about the infrastructure side of things. So I'll just invite Geshan up and take it away. Thank you so much. Cheers.
Love is like ghost, which everyone talks about, but only a few have seen. Same goes for serverless on production. Like everyone is talking about it, but I don't know how many actually have it in the real production running environment. Here I'm gonna just run through working serverless containers, like web app. For a containerized app, it's Google Run, but that part is going to be towards the end, like the demo. I'm just going to take you through a journey of why serverless containers in the first place. I'm Manandhar, software engineer at The Iconic. I call myself a tech service provider, and I'm just a microservices believer because microservices fit all needs. I'm originally from Kathmandu, Nepal, which currently forms more than $1 billion in the Australian economy with the students that come in. And it's the only country that has a non-mechanical app. As well, I work for The Iconic there. So this is basically going to be the agenda for today. First, we're going to go through what is serverless, why serverless, then containers, and why actually use containers. After that, some of the current serverless function as service offerings, basically the big three. that cloud spectrum, and then execute that into cloud. Let's get started. So, what is serverless? From Martin Fowler's website, it was actually written by Mike, who's I think is the CEO of Symphony, and says it's serverless basically can be divided into two things: backend service and functional service. Backend service is basically a fully incorporated third-party cloud-hosted application service, so you don't really need to think about the backend. And the other part, which is much more famous and much more provided by other cloud providers, is functional service, which basically is run state-based compute containers on an event-driven fashion, which are ephemeral. That means that it is not there for a long time. So basically, for instance, if you upload a file on S3, then you could create how many out of it. Or something happens. For instance, if you use Google Cloud Scheduler, if the clock hits 9, you do something. So all of this would be serverless and function as a service. So you just put a function to do that part of the job, and it does it. Now, if you think of it, is it the right time to use serverless? Is something many of us would ask. And I would say yes, also because Gartner in 2017 said, okay, serverless has come into the picture, but wait for 2 to 5 years to actually start using it. 2017 plus 2 years, 2019. So it actually makes it ready for that work productivity, and it is probably the right time to start using serverless. But if you think of it, we PHP developers have been using serverless decades back. If you think of PHP, all PHP processes must stack, so nothing is shared between processes. And we were kind of using it like decades ago. Even in terms of managing servers, PHP probably was ahead of the curve. Like even 10 years back, I could just throw my code to a server and it would run. I won't say it would be very well managed and scale everything, but it would still run. And yes, same goes. The execution model is still similar. You're not sharing between processes and things. It's dying, but it's not completely new. It was there. So why is serverless? These, I think, are the main points of using serverless. One is server management doesn't become necessary. You can live without it. The other is precise pricing of it. You pay by invocations if your provider provides it by seconds that it runs. And it is inherently scalable. You don't need to think about load balancing. What if I get a lot of traffic? It basically is scaled on its own. You don't really need to put an effort to make it scale. Similarly, it goes for high availability. I think most serverless functional service guarantee 99.9% availability, even though code starts with something you want to think about, but yeah, generally it's highly available. And as its smaller functions divided into making of an app, like more functions coming into making of an app, the deployment becomes very easy. You just want to change this function and not these functions. That is possible. Most other providers already provide like a UI or let's say like an IDE on the browser itself. You just go, you edit it, it could be done like that. There are other frameworks for instance serverless that you can actually do the own deployment process, but that's up to you how you want to deal with it. But deployments are very easy and fast. And the other thing is, it is actually fast to reach to a working application UI from nothing. Let's say if you go the VM path or containers or Kubernetes path, it takes a lot of managing into servers or things. But here, get your stuff done, so it works. So on this platform, you get a URL and stuff. Yes, look, it all boils down to the main idea that you focus on your application code rather than the infrastructure. You basically leave the infrastructure to the experts who manage thousands or millions of machines, and you just focus on your application and how you want to build it. In case of serverless, I think these of course the big three that provide serverless function as service options. For instance, the Google Cloud function doesn't really support Ruby or TypeScript as of now. And then, as I said, it is all event triggered, so you can even do it with HTTP or trigger events, for instance, as I gave an example, S3 upload, you go to file, and then you can get the thumbnail for that image. So those things are possible with serverless. Some of the things you might want to for is if your job is running too long, how long is the timeout? And there at your lambda kind of ways you have 15 minutes to use, so your functions will actually run for 15 minutes. Same things for the packet size. You could actually upload 100 MB of code even in Google Cloud Functions. That's I think a lot. So yeah, these are like the big three providers, and these are working hand in hand for functional service. But then again you come back to the same thing. Serverless is not serverless. The only thing is you are not managing them, someone else is managing it for you, and you just abstract it out just a bit further away. Now let's look into what are containers. Docker is very popular, and Docker defines it as a standard unit of software that packages code and all of its dependencies. So earlier, if you were just shipping code like let's say 10 lines of code change, and I want to put that into servers, now you're actually shipping the whole stack. It's the OS, all the dependencies, the programming language, your code, other vendor code. So that's why containers are powerful. Why is containers then? As I already said, the big difference is that it will ship the whole stack, including the OS or language version. So all of it will be fine-tuned. If you want to run, I don't know, PHP version 5 or version 7, to do that because they are completely different in two different containers. It is very easy to scale horizontally if you use things like Kubernetes. You can just set your port count or use a HPE as a port scaler and say, whenever I get more traffic from 2 pods, I get 5 pods. So that becomes a lot easier with containers. It is isolated. Every container has its own namespace, own space to play with. So that brings some form of security. And it does have faster initialization and execution. Plus, with things like Kubernetes, you could actually plan a multi-cloud strategy and multi-cloud is possible. So it might have its own plus and minuses, its own products, but it's impossible. Looking at it from a developer point of view, if you have, for example, Docker, someone could just on the first day do a Docker compose up and the whole thing is running. Okay, get a coffee and then the person is back, it would actually be productive on the first day. Let's go back to the background days. Someone had to actually get the virtual machine, try to get it running, and then, or even ahead that we had to install all of the things that we needed. Probably 2 or 3 days we were just installing stuff. We did not figure it out. But with Docker and everything as code, run 3 commands, we are all stacked there. And then it all boils down to you're just decreasing the distance between the dev and the ops. That's where the power of container lies. Yeah, nowadays the word SRE is becoming pretty popular. It's cited as engineering, which would say it's like the next level of DevOps, but it's something you find. Anyways, I think I was just having this discussion 10 minutes back as well. So basically, there has always been a fight for containers versus serverless, and these two tribes don't really want to go along together. So this talk is basically this. I want to build a bridge between these two tribes with serverless containers, and I think that's where the power is. And I go further into how that's possible. Let's look at a very short evolution of how the cloud has evolved in the past years. So when the cloud started, it was basically I want to put it in a virtual machine, I want to do my stuff on these virtual machines, I have external virtual machines, and that's how it all started. Later, I think it was probably Heroku, which was very popular, saying, give me your code, I run your code, you don't really need to worry about things, I will run the server, I will do everything. That's basically our service. I will give you a platform, give you a code, I will run it, I will charge you a lot of money, but I will run it. Yeah, 2013-14 probably saw the boom in popularity for containers with Docker. Containers were not great in using, but I think Docker packaged it a lot better and made it a lot more accessible to a lot more people. So 2014-15, everyone was going after containers. Everyone wanted to Dockerize their apps and use, I don't know, Docker Swarm, Kubernetes, Inter Kubernetes kind of came out of everything. And then the release of Lambda was 114 November, but it took some time for people to actually chew the fat, and then it used to be 115, 16. Then serverless started becoming the word, and other cloud players also came into the game. Pioneer was actually AWS standard. So in this, what you need to think of is how much control you have over the infrastructure versus the ease that it provides. For instance, for serverless, just throw your code to me, I run it, you don't have control over it. But with VMs, you have a lot of control over it. You have, let's say, root access to that machine. If you want, you can install Java, PHP, Python, everything on that, and then do a lot of things. Basically, you have a lot of control over what you want to run, how you want to run, what resources you want to allocate. As you go to the right, the control is not there, but the ease comes up. That's where the sweet spot is. That's where and how serverless containers can help you there. You still have access, the root access to things, but you just throw it to someone and then it's still runs. So that's where the balance is. Now let's step into one of the providers of serverless containers. I think AWS has something called Fargate, but I'm not sure if it's actually serverless. But they actually manage containers for you. You use containers for them, and they manage. Good Cloud Run, on the other hand, say that they are a managed compute platform that automatically scales stateless containers. You give them stateless containers, and they write code. And then it abstracts away all the infrastructure management for you. So it's all about how many requests can this container handle. Advantages, you don't really need to learn a new paradigm or a framework. For instance, if you are doing serverless and you are joining functions together, unless you have something like serverless framework, I think it's really difficult to build something sizable. So with Cloud Run, you're still following your own thinking and your own way of working. And you don't really need to learn a completely new paradigm. As I showed in one of the previous slides, with function as service, it is limited. Like, let's say if you want to run Rust, you can't really run on any of the big three or other providers. But with Cloud Run, as you are running a container, you can run on any language, any framework, any binary you want. So that's a very, very big advantage. We're not fixed by runtimes. It's not someone saying A, B, C, and D is available to you. You choose what you want, and then you run. The ground is open for you. Whatever you want to choose and run, it's possible because they are very used. And then it's fully managed serverless. Serverless, as long as you let people manage it. If you want to manage it on your own with KDB and KD, you can do that. But then I don't know how much serverless would it be because you are running your own Kubernetes cluster at that moment. And then it is very easy to get SPS URLs out of the box. You can even do custom domains on Google Cloud Run. I'll just show you one example. The other thing is all the goodness of Google Cloud toolset that you get. For instance, Cloud Build, Cloud Registry, so you can use all of it. Just plug in Google Cloud Run very simply because it's all in Google. And it's very easy to get from because nothing working URL. And then it's serverless plus containers in place for the developer. You get both the ease of working as well as the control. I created the demo box that nothing breaks, and I'm still going to go to the Wi-Fi. I'm just going to show you a very simple application. That's the currency API. We just give two currencies and a date, and it just gives the conversion rate for that date for that currency. So basically, it's that open source. Let's just go ahead. I don't know how many of you would actually get the part of it, but it's a very simple less than 100 lines app that just fetches stuff from one API and then keeps it back. And here I am just going to show a change the UI. So nothing much has changed, only these words here. Okay. So let me start. Basically, I have an app which is containerized, and Google Cloud Run says that we need to expose this particular port, which is get 0 and 0. That's and yeah, it's a Node app, Node 12, I think on the app here, just a single Node app running on port 80. Yeah. And I have already built the containers, so these are the two images that I assume that most people know how to build at least. So I just built a container and tagged it something here, and then it creates a container. I'm not doing it here to save bandwidth as well as to save time. So these are my containers, and I just push them to this here and that tag. Yeah. Okay. So as soon as I've done that, these will of course come to my stream. Yeah, so the project is test project, that is expense API, and I have these three containers right now, which is the latest and something that I changed just to show that how easy it is to run. Yeah. I just try to create a new app if everything is successful. See, if it's fine, yes, I have a show. So I create a new service as it's all Google chain. I just need to select the container that I push. So even building and pushing the containers, you can just do it with Cloud Run if you want. I just did it over for demo, but depending upon how you want your pipeline to be, you can just build it on Cloud Run with one file and it's for Cloud Run. That's it. And then on every push, you just configure it from GitHub and just put. So basically, this is the artifact that you have. I don't think Cloud Run is available in any other Zoom as of now. I just give it a different name because I have say there with it. I allow you to have authenticated indications because that's not your public area. And you could add other options like memory or different variables and stuff. I'm not going to do it because my container has everything. Let's see if this creates so fast enough, else I will show the other methods. Okay, so while this is running, as I already have this here. So this is basically after that completes, you just get a URL, give it the URL, and it's already working. So yeah, this is the main page of the app. As it's an API, it just says give this URL and then get going. So I'm just waiting. It basically says from USD to AD, today's rate is 1.433 something. That's that. February. It gets it. It gets it and it's big. So basically, it's calling that API. It gets the particular rate. It saves it on the database as well as makes it back instead of parallel processing because that's possible. So meanwhile, let's see if the other app is created. Yes, that was fast. And the same thing. Both of them are the same app, so they are going to have the same data. That's how easy it is. I had code, I had a container, I just built it, pushed it, and deploying it with the UI was very easy. The other good thing of Google Cloud Run is you can actually map to a custom domain. This is my website. Of course, you have to verify a domain, and then same app is available. The same app is available here as well. So custom domains are pretty like something that they provide, it's already there. If you want to snap it, just prove that you own the domain. Now, what if you want to deploy a new version? Yeah. So I'm just changing the home page. These words changed from API Lite to API infrastructure. Nothing much changed here. And I'm going to deploy that particular launch. So it's pretty easy to run version. Select the right container because every push should be on container. It's containerized change. Container. So deploying is very fast as well. This takes quick to deploy. Yeah, very efficient too. And all of the deploys are here. If you want to read it, that's possible. I don't know why they have this. Sorry, it was a traffic change, but it doesn't actually work like that. So yeah, I just deploy it now. And if the deployment is fine, it should change. API Lite became API infrastructure. So this is just an example of some change to deploy a full app like this. It's very easy. Just go there, click 2 buttons. Given that your doing pipeline is set up correctly, deploy should be. So after I tested out, I actually tested the Google Cloud Run for some friends of mine. They were doing a college project. We actually set up a full codex container and then tried to deploy the app. But then one of them, the guy who was handling DevOps said, okay, I'm not going to do it anymore. Then he shut down the container. The whole Kubernetes cluster, and I was, okay, now how do I give this guy a coding work? And that's when Google Cloud released at came around Meetup. And I was just going around with it. It was so easy because as we had already dockerized the app, all of the containers images were there. I just clicked 3 buttons and I could see a URL. It worked. It was okay. Wow, this is good. That's how I came up with this stuff. But then after fiddling around with this, I wanted to do a comparison between how is Google Run different in terms of performance with Google Cloud Functions, because that's what is already available. So what I did is the same currency app, I put it into a Google Cloud Functions, same app, nothing changed. Like I need to change 2 lines for it to be compatible as functions, but no logic change. And then same resources. The results were astounding because I don't know, like Cloud Run responded within 2,000 milliseconds, so around 2 seconds at the maximum, and then it went down. So what I did was I did 10 requests per second for 30 seconds with Vegeta. If you don't know Vegeta, you can check this. This is a very good tool to do performance testing and load testing like this. And for Cloud Functions, similar specs, same app. Like it started at around, I don't know, 6, 7 seconds, reached up to 8.5 seconds, and the least I saw was 700 milliseconds. So I'm not sure because Google Cloud Run is in beta that they are giving it more resources, or is it because as Google Cloud Run shows that if a container is already up, if it doesn't spin up another container, it just reuses that container. So it's documented in the Google Cloud Run process. I don't know what the reason is, but like this was pretty a big difference that I saw while I was testing it. So, sorry? Yeah, probably, but still it was like 100 to 2.5 seconds, but here it was, yeah, this is the cloud function one, this is the cloud repository of the installation. Yeah, exactly. I think it was the same container because I was hitting it like 10 meters per second, so that container didn't die, and then it just used the same container, reused it over and over again, and that's why I thought she used it. So yeah, right. Exactly. Yeah, yeah. But like this is prudence, so every invocation has to be done. And that's all it. The icon is hiring, we're having a platform engineer, someone with a security background as well. I think product owners as well. I don't know if you explain what that is. And yeah, I log at additional component key, involving computer, and this slide is available. Maybe a bit different version of it. So this is zero, and the slide is available here as well. I'm in questions if we have time.
Absolutely. I've got a microphone if you can ask one.
So just a question about scaling. So for example, your application, let's say if there's a concurrency of like 100 people or 500 people like calling your API, and if I haven't mistaken, you're actually making another downstream call to other APIs. So it's more like I/O bound instead of CPU bound.
Yeah.
And with the scaling with GCP run, I'm not sure if it's kind of supporting I/O bound sort of scaling criteria, or it's only CPU and memory. Thank you.
Okay, that's the thing with serverless. I don't know what they are doing because I can assign memory, and I can say how many concurrent requests can I send it to one. Two, this app actually does a caching. If it's already there, it just gets from the DB. It doesn't hit the URL. But let me just check here. When I deploy, I think the thing that you can actually configure is the memory and maximum request for that container. So these are the only two things that it allows. Again, going back to the graph, you get the ease, but you have the control. So it does CPU and everything. It's all up to them how they want to handle it.
So you can't scale it
based on CPU, then probably you need to go to Kubernetes, native, and manage it on your own if you want to. Because as of now, these are the only two things that you have control over when you want to deploy that.
Can we do Kubernetes? Like Kubernetes has its own like custom metric and things like that, and you can scale based on that. Is that possible with Cloud Run?
With Cloud Run, fully managed GCP, I don't think so because these are the only two things available. It was just released in April. I don't know if they're adding it on now. But yes, with Kubernetes, you can have a lot of complex tools that says if CPU is 60 and memory is 80, then only scale it. So you can have these and services. They will be there.
In terms of architecture, if you have hundreds of microservices, what would you recommend?
That's a very good question. Depends. I think it depends on the case, like what you want to do, and you could try to go with serverless, but how will you manage the code starts and everything? Let's say if you are a news website, that would be a big thing because the first person would be waiting, and then the second and third person would be getting task. But it depends upon the use case. I actually do or did a talk a state from two on this one microservices. But yeah, much of it was not serverless, it was with servers, and most of it was handled by Kubernetes. So as of now, my opinion, because I don't have much production serverless experience, I would say the safer path might be with servers, containers, Kubernetes. But Peter might have a very different opinion on it. Yeah, that's the thing. So it depends upon the particular use case. If it's a startup and they think that they're going to have 1,000 visitors a minute, probably it's good to offer serverless. So it depends upon this.
So you mentioned that your application queries data from a database, right? So what happens to that connection history? Does it go through all the internet, or it goes through a private Google connection? Like, for instance,
Right now, I'm not setting up any of the IAMs or anything. Right now, it's just a Google Cloud SQL instance, and just to make things simple, everything is in Google Cloud because I was doing functions and Cloud Run, and if it was in a different place, it would be complicated with the data and everything. But right now, this is just a demo application. I haven't really configured all of the access and stuff. But what was your question?
Yeah, no, I mean, it's like, if you compare like an application that is running on a Kubernetes cluster, where, like, for instance, using, I don't know, Azure Kubernetes services, you can probably use like Azure CNI and connect to a database through the private VNet.
Yeah,
going through a call.
Even with this, you will just set up a PC and get stuff. That's what. But for this demo, I think you look for that.
I was going to ask you a couple of the performance comparisons between Google Cloud Functions and Cloud Run. So yes, they're both in the same region.
Yeah.
Database that you're using, same region.
I try to make them as same as possible. One line of code is changed because Google Cloud Functions wants it to be exported out. That's why that was changed. Except that memory, region, everything I just put it the same so that I'm comparing apples and apples.
Yeah, well, good. The other question was, I guess, one interesting thing I was thinking about Google Cloud Run. I think it's basically you need to have like a container that's a web server. You can't just run random container-based jobs. You can.
I was looking at the implementation of the itself, and one is what I did was I did unauthenticated. That's why it's public. You could actually do IAM and then try to figure that thing. So in previous services, where I did this, but you could actually deploy our application just do it inside the Google Cloud IAM, etc. As far as I have read the docs and checked the recommendations, they say you could use it with Google Cloud Schedule. So let's say if it's 4 a.m. and you want to run something, you can do that.
So like a HTTP endpoint.
I think it works even without HTTP. HTTP is one of the ways to implement it, but it can be done even based like uploading file on Google with storage or whatever it's called. I pass it as far as I remember. That's possible.
Have you compared the cost of these two services on the same functionality and on a heavy load or light load?
Actually not, because I think the first million or something was free, and as Cloud Run is still in beta, I think they're free finalized the cost for it. But I haven't been compared because I don't know exactly what it means. But that particular graph was just 300 requests, 10 requests per second for 30 seconds. That's a very small data set to actually tell anything, but I just wanted to show something that I can just do directly.
Last question.
You could run whole web apps with containers, couldn't you? I mean, I know people are doing it with functions as well, and they're actually having a function that has a web app, and it's got a CDN behind it, so all the data, most of the data gets cached in the CDN, and the function just calls another function on it to do something.
Exactly. I think that's where Cloud Run has the power, because if it's container, you need to think of function A, function B, and all of that. It's everything is inside your container, and you have the whole code base. You can use the framework you are very comfortable with. But if you are doing composite functions, joining functions, probably that's where you will need something like the serverless framework, where you actually do everything locally, then deploy.
They get around the problem of long-running functions. So you've got your container app that's running like web app servers, and then you have your functions kicking off functions like little functions. Happening in 2 seconds.
Yeah,
so you got the best architecture.
Exactly.
I mean, I build web apps that do that. I have web apps and then leading functions offshore. I just kick off your function.
Yeah, that's fine. That's totally fine. Nowadays, like if you don't make your web apps stateless, it could be an issue. I don't know if you start saving sessions or devices or something, it is already a problem. And that's where containers, the stateless containers makes it pretty. Yeah. Yes. It particularly stays stateless containers. Yeah, it particularly stays stateless. And functions like FAS is the same. You cannot share something unless it's saved on third party somewhere like S3 or other files.
Awesome. Cool. Yeah. Amazing stuff. Thanks very much. So again, another shameless plug. Geshan will be speaking at Serverless Day Sydney on August 27. We'll have a quick little break, grab another drink or something while Simon Quake gets set up in his next presentation. Thanks. Yes, if you need a bathroom break, it's just around the corner out the door. I like you used to Forest Brazil cartoons, man. Love them.
Yeah, that's what I was thinking. Is that similar to other containers? Or is it different?
Yeah, I guess it is.
Okay, yeah, it's very much the same.
Yeah, it's more akin to because of the short durations, then the scheduler then is also service. But that using
I agree with what you're saying, but let me
Alright guys, I think we're ready to go. Up for the second talk of the night, we've got Simon Wade, who is a developer advocate here in Sydney for Microsoft Azure. He's going to take us through, obviously, customized serverless using Azure Functions, Container, and Header. I think Header is an amazing development. Like, where usually serverless wins out massively compared to Kubernetes is event-driven architectures. And Simon will take us through how perhaps you can have the best of both worlds given all these animate-driven architectures all in one place.
I realise I've missed the name here. That guy doing magic. No magic here. Thanks a lot, Pete, for the introduction. Welcome everybody this evening. My name is Simon Wake, as Pete said, I work for Microsoft. This evening we're going to talk a bit about serverless using Azure Functions, host runtime environments, Docker containers, and Kubernetes, and then specifically look at Kubernetes event-driven architectures, or KEDA, which you may or may not have heard of before. This is a bit of an interesting talk. When you talk about things like Azure Functions or Cloud Run or AWS Lambda, you start to talk more about platform-specific features and capabilities that are tied to a particular vendor. While Azure Functions definitely started its life on the Azure platform, I think as you'll see, it offers outside of Azure a lot of value as well, particularly if you're considering moving to a event-driven style of development. Notice that we say serverless, event-driven. That's the key word here. And hopefully after this talk, you'll have a bit more of an idea about what my thinking is, and hopefully share a bit of that vision. The scenario I want to use for the demo and kind of to get you thinking about this, and it's a little bit like the demo in the previous talk. It's a little bit contrived. It's meant to be massively real world, but I think it's something that we've probably all experienced, particularly if we've ever used and uploaded videos to something like YouTube. The idea that you're going to create thumbnails out of videos that may be 2 seconds to 2 hours to 2 days should be a fairly common idea. And it's something that can be done asynchronously. So I upload a video and I don't necessarily immediately expect thumbnails to be available, but I think it makes a good candidate for running in an event-driven scenario. So basically this evening, I haven't got a web application that I'm going to upload the image or the video through because I'm not a web developer, much like me. I wouldn't like websites to save my life, so pretend that I'm uploading via a web app. We're going to write the video file into an Azure storage account. We're then going to write a message onto an Azure storage queue that says, hey, a new video has arrived for processing. We could notionally attach an event to the storage account and have the storage account create an event on the creation of the file, but I want to have a bit more control over when and how that video is processed. And then I'm going to have a function that's triggered by the presence of that queue message to download the video, process it, create thumbnails, and write the thumbnails back up. So it should be hopefully fairly simple scenarios to understand. So the bigger the file, obviously the slower that thumbnailing process is going to be, so I think that's a key idea to get back in mind. Now, we could notionally write this function and run it in Azure on our Azure Function app, either a consumption plan which is sort of paid just for what you use, or on a service plan which avoids cold starts but at a fixed cost. But as we'll see, there's a bit of a challenge to do that. I want to take a step into the Docker world, and this is a supported deployment mechanism for Azure Functions. You're not required to build functions and deploy them just into function apps inside of Azure. You can actually create customized container images that host the function runtime, and then deploy those images into Azure Function apps. Linux only at the moment. But I think this is a really good way to start thinking about doing functions development beyond just doing code deploys, because all of the dependencies that you require, whether they be extensions or the runtime host itself, are packaged up into that Docker image when you build it. So everything you need to actually run and start that function, regardless of where you deploy it to, is already present in the image. You're not actually having to rehydrate that at first execution. So hopefully we'll see over time reductions in things like cold start times, particularly consumption scenarios. Portability. Because it's in Docker, you can take your container anywhere. Now that might sound odd. This is an Azure Functions host app. Why would I run it anywhere else? Well, I think when you get to the end of this talk, you'll see where I'm going with that idea. Just get your own local. And then I think it's a much more common code development lifecycle scenario for people now. So serverless has certainly suffered over the time that it's been a development paradigm with a fairly low level of maturity when it comes to doing things like unit testing, security scanning, continuous integration, continuous deployments. It's certainly matured. The Azure Functions team, as we'll see, has kind of built a really good local development experience, and then we've got a full CI/CD experience, but not every platform has that. And maybe you don't want to invest your team in understanding how to build, deploy, and maintain functions code. You just want to be able to build, deploy, and container images. And then finally, if we Dockerize these things, maybe you're an organization that's doing a lot of heavy-duty Kubernetes already. That's your go-to for hosting applications in your modern environment. So why should I have to learn another hosting paradigm? Why should I have to understand how to run Azure Functions app? Why should I have to understand Azure PaaS, platform as a service, when I can use Kubernetes? So maybe I want to use the existing expertise I have from a platform management perspective and benefit from the serverless development, event-driven development paradigm. Okay. Up until now, it's been a bit of a challenge in the Kubernetes space. Events in Kubernetes have been fairly raw and generally have been converted down into HTTP requests to make use of the existing capabilities of Kubernetes to scale off HTTP. But as we'll see today, Kevin solves some of those scenarios for us. And then finally, I think big thumbs up for me. Who here does serverless day-to-day for their job? Ish. Who wishes they did serverless day-to-day for their job? Okay. So you might not be surprised to hear that security people don't really like serverless an awful lot. They do it as a potential leakage point in their applications, particularly as you've got these little bits of code that might run on the edge of your environment, so like their function app, maybe Cloud Run, maybe Lambda. Keeping those things secure and making sure that you're happy with what's being deployed. Do you know what your developers deploy as part of their serverless code? In Lambda, I can drag and drop and deploy binaries with my Lambda code. Can't do that in functions. You can certainly deploy it, but it won't execute. But it represents a risk. And if we containerize these things, we can then push the container through standard container security scanning technologies so that we know when we come out the other end of that security scanning process that the container we're deploying either into Azure or Kubernetes is security, or at least we're aware of what the CVEs are in the underlying container. So good so far? Looking for time bombs, yeah. The only time bombs in my functions is using my code. So how can we create an Azure function Docker container? We'll have a look at this in a moment. We'll give you a bit more of a feel for how you go about doing this. So if I've created an Azure function already, I can retrofit a Docker container definition over the top of it. I don't have to start from scratch. So I can have an existing function that I've written, and maybe I make the choice that I want to move to a Docker container. So I can certainly do that. And that's what the first command does here. So func, FNC, is the function's tooling runtime CLI that you can do lots of different and amazing things with. Init is just a command that says, hey, we want to initialize something, and then pass it -docker, which says, okay, create a Docker file for us. So let's go ahead and do that. So here in my Visual Studio Code, I'm editing a function. Let's just close console. Now you'll notice in this that I've got a nice little green bar down here in the corner of WSL. So I'm actually editing Azure function running on Windows Subsystem for Unix on this host. So my files aren't running inside of Windows. And the reason I'm doing that is because the scenario I want to build this for. If I try to do it on Windows, I can certainly do it. The FFmpeg binary that I'm executing is available for Windows, but then I get into the whole what path do I need to use because I'm on Windows or Linux. So I prefer to avoid that, so I'm using Windows Subsystem for Linux, which just gives me native Linux capabilities. I have an existing function, which is called a video thumbnail processor. It's written in nodejs. I apologize for any terrible JavaScript. I'm not a JavaScript developer. I'm also a lazy developer, which is why I found this great package called FFmpeg Generate Video Preview, which saved me having to go away and figure out how to do all that stuff. Needless to say, it requires FFmpeg to be on the host though. And then I'm doing a bunch of other things. So just take a quick look through the function. I'm grabbing, the event is triggered by a new message on the queue. Queue message contains the name of the video file. For this scenario, I'm assuming that the blob storage account container of the file is just hard code, just to keep the demo simple. But the queue message will just be the file name. So when I receive, or when I'm invoked, I know that there is a new message on the queue. The message queue item is just, that's the name of the file. Create a new Azure Storage blob service instance, and then I go and download that file. Now I'm using another nodejs package called Chokidar. The reason I'm using this is, I don't know if you've ever tried to invoke binaries in a Linux world, but oftentimes binary will exit and say I'm done, but whatever it's producing is still potentially locked or not available on disk because it hasn't been streamed out of memory onto disk. So what Chokidar allows me to do is it allows me to watch for the creation of the file. So I can use an event that says, hey, the file was created, now we have a file that we can upload. If I don't do this, often I'll run into a scenario where the thumbnail file won't be available and my nodejs function will blow up. So I have the capability to do that here. I call generate preview, which is part of the FFmpeg preview package. I provide it with some inputs, so my video file I've downloaded, preview path which I built would just be a JPEG, how wide I want the image, what the JPEG quality is, and then the number of rows and columns. So what that's doing is, if we have a quick look at the sample for this. So here's a video at the top, which is just a person making croissants, which are both delicious and fantastic to what's being made. So it's only a short video, and then with this thumbnail processor you can create. So this is 5x10 thumbnails that are snapshotted at intervals throughout the video. So that's what the FFmpeg preview package allows us to do. So that's what we're doing in our function code. Now if I run this locally, so I'm just going to plug this. This is not using Docker at all at the moment. This is the local function runtime environment. Okay, so that's now up and running. So the benefit of using this way of developing is we don't have to have anything special. We don't have to download anything onto my machine other than the functions tooling. And what I'm going to do is I'm going to come up into, so this is Azure Storage Explorer. I have a queue here. There's nothing in the moment. I'm just going to add a message. It's really high tech. I'm going to call it baking.mp4, which is the name of our file. Come back over to our functions. You'll see that it's already seen the message. So it's downloading that MP4 file down onto my local machine. Thankfully, it's not a very big file. And it's going to do the processing. Okay, so it's done with the preview creation, then it's going to upload that file back into Azure Storage. Now, notionally, I could use a stream. Unfortunately, the FFmpeg package I'm using doesn't process streams. It needs to have the file locally, so I'm downloading the file locally to make this more efficient and be great if I can do it with streams. So that video has been processed. If I go back up and I have a look at my thumbnails folder, there's my thumbnail which is created. Okay, so that's pretty cool. And that works locally because I installed FFmpeg on my Linux box. But FFmpeg is not a standard binary that's deployed. That would be fairly common in a lot of environments. You have fairly bare bones Linux box or Windows box as your runtime environment. The standard functions runtime environments in app service, you can't customize them. You can deploy the code and whatever is on the host and whatever you can deploy as part of an assembly or whatever with your programming language, you can deploy that. But if I try and run FFmpeg on a fresh Linux environment, I don't know that. So I'm running two versions of Ubuntu on my host. So this is a fresh version of Ubuntu in WPLAN and WSL. It doesn't have FFmpeg in there. Now I can solve that. These enough we're doing apt-get and a whole bunch of other like, which gives us some idea of what we're going to do next. Now if I try and deploy this up into the Azure Functions environment as is, without doing anything else, it'll fail. Code will deploy, but when it tries to invoke the npm binary, it'll go boom, and I'll get an error and things will end badly. I want to Dockerize this. That's going to be my first step. So let's go ahead and Dockerize. This is just going to stop the debug. I do love the fact that my bash console here, even though I'm in Windows, is actually bash WSL as well. What I'm going to do is I'm going to do func init, dash docker. I should go through that. Go custom docker, go custom that. It's custom runtime. This small runtime release package. Alright, now I cheated, I did some of this before. I'm new, thankfully, to doing demos, so I know they fail, how much typing is pretty bad. So there are a few files that it skipped. That's the great thing, is it won't overwrite anything that's already there. Now it's created a new Docker file for me. This new Docker file is not great. It's doing pulls from the Microsoft Container Registry for our baseline node runtime host. Now I can go back and I can find that Docker image. I can find that Docker file, and I can modify those. I can create my own if I want to. Now then you're into probably questionable territory from a support standpoint from Microsoft, but there's certainly nothing that stops you from doing that. It's literally pulling the baseline, which has got the Azure Functions runtime environment in it. It's then copying across my source code, and then making sure that it's checking on the logging locally, and then it's just doing the npm install, because it knows that this is a JavaScript host, so it needs to install any of my modules. Now, what I'm going to do here, again, I'm going to cheat a bit, is I'm going to copy across this little bit of magic. And I'm going to put this there. So what's that going to do to my Docker file, to my resulting Docker image, if I do a Docker build on that? It's going to put an extra layer, and that extra layer is going to include everything, which means my resulting deployed Docker image is going to have everything in it, which means that my problem of not being able to access it at runtime is going away. So let's go ahead and build that. Terminal. What I'm going to do now is this is going to be a standard build. In fact, I'm going to do it lazy to go through the history because I will match this to one command. Now I'm going to push this up to Azure Container Registry, ACR. So I'm going to tag it using my ACR function, and I'm going to increment that because I've already got a few versions up there, so it's going to increment the version number. So when we build this, we've got a bunch of cache layers already locally. You'll see now it's actually installing it with npm. Now when I first did custom stuff in functions, I was rather annoyed that I couldn't just do like lambda and drag and drop binaries up. But I actually think it's a much better way to do things, because from a developer standpoint, it's very comfortable for me to go, oh, I need some extra dependencies here that aren't part of my deployment package, my code. I can put them into a layer, and so we've got that. While that's building, because no one likes to watch building happen. Inside of Azure, if I want to run this function app, when I create a function app, hard to see. When I create a function app, oh, look at that, my demo app isn't available, someone's already registered. You'll see here in the middle, and I can do this by the command line, I'm just showing it graphically because it's a bit easier to understand. I can choose Linux as my operating system. If I just want to push my source code, so I don't want to push Docker, I can choose code. I can tell it what runtime stack I want, so it's going to go away. It's going to pull that baseline nodejs runtime environment that we saw in the Docker file and deploy that for me, and then copy my code over the top. My suspicion, not that I know for sure, is that it's just doing a Docker build behind the scenes, so it's doing that for you. Otherwise, I can choose Docker image. If I choose Docker image, a few things will change. I can't deploy to a consumption plan at the moment, it has to be to a fixed plan. And then I have to choose the container that I want to deploy from. So I can choose to deploy from any number of locations. So I can either deploy from a Kubernetes YAML file into app service.compose or a single container, and then I can choose to deploy from container registry .hub or some other private registry that's addressable inside that. So I'm going to use ACR. I'm not going to go through and do this because that's not the purpose of tonight's talk, but the Docker which I'm building could be deployed into Git using that as the target, and it will run okay with FFmpeg. So that's our fully managed way to do things. If you don't want to touch Kubernetes, you can use that like a container to run this environment. Okay, I'm not worried about the red, that's just NPM complaining. Thankfully, people who are working on NPM decided they were going to make up and get back to working with one another. So that is now built. Now what we're going to do is we're going to push this up to our Docker container registry, so Azure Container Registry, which is a private container registry that I've got cited inside of Azure. This is stuff in the history. And I want to make sure I push the right image. Okay, now this is an update to an existing container image, so it should be pretty quick. It's just going to push up the layers that have changed. Good. Start from motion. Right. Let me push through. Now I've got that Docker image up in ACR. I can option it anyway. Got free to do that. I'm not tied to that as much as you want to do that. I'm going to hop quickly back over into slides though. So that's kind of the baseline. Containerized Azure functions. Pretty easy to create. And you can even do it with existing functions that you're running today, assuming they're the version 2 functions, if that makes sense. Demo. I can take that, I can run on ACI as well as run to Azure Container Instances, which is actually what we're going to do with Kubernetes. Read the docs. It's all documented. Nothing I've done here is hidden or private. We have it well documented on the docs site around how you can go away and build your own custom containers. You can run them locally, use Docker run if you want. You can do that step. So that's Docker. So let's talk a bit about Keter. So Keter came out earlier this year in May, and Keter is a project that's being worked on in conjunction between Red Hat and Microsoft. It's actually an open source project, so it lives up on GitHub. It's open to contributions from any number of people in the community, but the people who are steering it at the moment is a combination of Red Hat and Microsoft folks. I know that there are some AWS people that have been committing code in there to enable the ability to connect Keter events into SNS inside of AWS. So there's definitely people across the community that are interested in Keter and what it offers for the maturing serverless market. Unsurprisingly, out of the box, given we've been working on it, Azure Functions is natively supported. So we've built tooling around the outside of our functions capability to allow you to deploy functions inside of Keter easily. On the Keter GitHub website as well, there are examples of how to do Keter without using functions. So there is somebody who's written some RabbitMQ examples that are tied directly to that, I believe, just written natively in Go. Keter is interesting, like I said at the top. It's different to how you would have traditionally done scale-based HPA metrics driven scaling before. So it doesn't look at CPU, it doesn't look at memory, it doesn't look at like HTTP queue length. It actually introduces the idea of a scale object. So you deploy a custom resource into your Kubernetes cluster called a scale object. The scale object consists of a scalar, and the scalar is the thing that is native event aware. So it has to be implemented. It doesn't use HTTP out of the box, it's actually native aware. So the demo I'll show you is using Azure storage queues, and Microsoft's gone away and written that event trigger Azure storage queues for the scale object. And it's an open spec, so anyone can go away and write native implementations. As long as they can write it in Go, they can write their own scalar and they can take advantage of it. A high-level overview of how it works. If you're familiar with Kubernetes, most of this diagram probably makes a lot of sense to you, but Keter consists of a scalar, a controller, and a metrics adapter. So all we're doing is the scaler is a thing that is aware of the external events. There's a definition which we'll have a look at that determines what the trigger event has to be, what is the metric that this external source will cause the scaler, tell the controller, to tell the metrics adapter to force the HPA to scale out and create new instances. So the horizontal pod auto scaler inside Kubernetes is the thing that's managing the scale of your workload across the pods. And all Keta does is it basically introduces a metrics adapter that forces the HPA to behave as though CPU or memory or what have you that triggered a scale event on the Kubernetes cluster. Question that some people often ask is, does this work with HTTP events? So that's a standard out-of-the-box Kubernetes feature, and it does. It sits alongside of that. So the difference with an event-driven architecture, like say Azure Storage Queue versus HTTP, is more often than not that HTTP request, as we saw before in the previous demo, is probably going to be going to the pod directly because the workload that it's requesting is already running on the pod and is serving a HTTP request on port 8 or 443 or whatever it is. Whereas an event-driven architecture, something like a storage queue is just creating the event, but the actual processing that's being done isn't actually being sent to the pod, if that makes sense. So we're not making a call from this event to that pod, we're making a call from here to the scaler, and the scaler is telling the pod, hey, a new event happened, and then the pod is spun up, and then the Azure Functions code inside it knows what to do with that external event source. That's a two-step process. And this, I just took this straight off the Keta documentation on GitHub. So again, nothing private or new. How do you install Keta on an existing Kubernetes cluster? I chose to do it using the function command line tools. There is a Helm chart you can use to deploy it, or you can use just a raw YAML file if that's your thing to go away and deploy Keta to an existing Kubernetes environment. Because I have an environment where I have everything configured and it knows through config which cluster I'm installing on, I don't have to supply anything other than func Kubernetes install, divided the namespace, and it will go and deploy a custom resource into a Kubernetes environment that will allow Keta to be made for me. And that's all I have to do, so I don't have to do anything else. How do we deploy into that? So we already did the Docker image build and we pushed it into Azure Container Registry. I could use Docker Hub or some other registry as long as I can create a reference to it from inside of my Kubernetes deployment environment. And then the functions tooling has provided me with a deploy command. Now I can do --dry run, and it will do basically a what if. It will show me what will happen when I run this, what's the output YAML file. The easiest way to do is to do that one once, save the YAML file for later, and then you can basically use kube control, apply deploy YAML to deploy that file. So let's go ahead and do that. We're going too quickly, or so good so far. If I'm deep in Kubernetes land and it's not making much sense, I apologize. And just give you feedback afterwards. Sorry? It's a serverless meetup. Oh, you know, serverless on Kubernetes is the future. Everybody knows that. What was that? No one spoke up. All right. So let's zoom in on this one. So I'm going to cheat it here. I'm going to create a deploy YAML file, and then I'm going to immediately override it. And the reason I'm going to do that, I will explain in a moment. Really boring. I'll zoom in just so you can see. kubectl, front deploy, custom node registry. So that's my ACR. I told it JavaScript is my runtime environment, and I'm going to deploy.yaml. The functions tooling has got some intelligence built into it. It knows what to do with things like functions configuration. So it knows how to write secrets into the YAML file. And it knows how to map my Azure Functions host into a scalar or a scale object definition. So let's go have a look and see what the YAML file looks like. Now, before we do that, we're going to cheat again. What we'll do is I've got one I created earlier, the good chef created one earlier. Hopefully the white space involves BPs. I know that would be angry with me. So first of all, it's gone away and it's created a bunch of secrets. So it's done things like taken all of the functions runtime and basically converted it into secrets, which are not very secret if you know what they are, but at least they're not in plain text. With my customization, all I did was I changed some of the metadata definitions so it's a little bit neater. So the functions tooling by default will create a bunch of metadata where it just copies the function project name. I wanted to call it something nice and easy to remember, so I renamed it functions, video thumbnailer. Creates a deployment. And then the first change that I make to this is, when I set up my Kubernetes service in Azure, my container registry in Azure, behind the scenes, Azure knows how to connect those two things together and create secrets so that they can talk to each other. When I did that, I did it with an account, didn't have necessary permissions in Azure to create that relationship, so I had to manually go away and create some secrets to allow it to pull the images out of ACR. So that's the first change. And then I want to use this fantastic thing in Azure called Azure Container Instances. So Azure Container Instances are the equivalent of AWS Fargate. So they're containers on demand, they're designed to boot very quickly, to run a workload and then go away very quickly, so you don't have to pay very much for them, they don't have to hang around for long. We wrote the virtual kubelet, which is now open source available to the community, which allows you to bolt Azure Container Instances and things like Fargate into Kubernetes, and they basically act like a bottomless node. So you can schedule workloads onto a virtual kubelet, and you can just keep on pushing pods into it, and it will just scale. I'd say indefinitely, but then I'd be sort of steering into the marketing parlance and realities. It won't scale indefinitely, but it will scale much more than a fixed virtual machine sitting under the covers serving as a node. So in order to be able to get up to deploy our workloads into ACI, we need to add a tolerations operator exists. If we add that, excuse me, then Kubernetes will allow us to push these pods out onto virtual kubelets. Here's our scaled object definition. So this is what Keta has built or deployed as part of its custom resource definition. The interesting thing in this is this little bit at the bottom. So here it knows that the trigger type is Azure Q. So that's a custom implementation that we've done, just as easy to say AWS SNS. IQ item is the name of the incoming trigger message. It's a Q trigger, so that's the type of trigger that Azure Function is using. It's in. It's inbound or outbound. The Q it's looking at in Azure Storage of new videos. Now I've modified this, so I added Q length here. By default, Q length for this definition is 5, which means that when it hits 5 messages in the queue, it'll scale and it'll create another instance. And it'll keep doing that until it hits that threshold. There is a cooldown period you can define so it doesn't scale many instances at once, or scale back in many instances at once. But for this demo, I wanted to do Q length at 2, so I can quickly show you it scaling to more common pod. Otherwise, I'd have to type really quickly or write code as command lines to pump in enough messages to cause it to scale. The scaled object definition is published up on GitHub, including all of the definitions that allow you to go away and tune the behavior of these items. All right, so I made that change there. Change the Q length to 2, and the other change I made was to the tolerations to allow it to use ACI. The other thing that Keta gives us, and this is a bit of an advantage for me, and I hope that eventually managed Kubernetes on every platform supports this, is the ability to scale to 0. So you can have 0 functional nodes or pods at any given time. So at the moment, Kubernetes AKS requires you to have one fixed node, which is one virtual machine, which is something you're paying for permanently. We don't charge you for the management plane, that's free. That's usually 3 virtual machines, so we don't charge you for that. But the minimum requirement we have at the moment is one always on node, so we're sitting there. With scale to 0, which is an open source project that our team who were part of Datus created. It's a project called Project Psoriasis. It allows you to scale workloads to zero. So here, because I haven't defined anything in my scale object definition, because this definition doesn't include anything here, by default it will scale to zero. I can put min and max counts in here, so it'll scale between those. So if I always want one of these things running, I can add a min count in here of one. But because I don't, it will scale to zero. So let's go ahead and deploy this. Check. Let's mash the keyboard for 10 minutes. There we are. Probably does. Alright, so because I've already set up my Kubernetes connection, fingers crossed, I don't need to do anything. This, famous last words. So this was already unchanged, but I'd already deployed previously. Configured my secrets, I added the secrets, so it added the secret in for me, and it deployed the code for me as well. So we can go and have a look at Kubernetes and have a look and see what the deployments are. Okay, so there's our custom code. Our nodes. So there should be no nodes. So there should be 2 nodes. With our virtual node, which is ACI, and then our agent pool, which is all that back-end stuff. And then what I'm going to do is just going to do CTL, get the pods. So I should have no pods. So the pods is where the work runs when it's actually executing, so it's not funding any resources. What I'm going to do is I'm going to do watch on that. So it's going to sit in the background. So this is taking that Azure Functions app that we already containerized and just put it into Kubernetes service. So there's nothing there at the moment. And what I'm going to do, see how fast I can type. Yes, I can batch insert if I wrote a command line, but I'm not going to, so I'm going to do bacon.mp4. Let's take a copy of that. Should hopefully see. Working. You can look at these. We'll make a layer up. There we are. Right, so that's only creating a single instance at the moment. I haven't put enough in that image. That'll be. Copy and paste and updates. That looks better. Okay, let's try it again. So there's probably still pods hanging around. Have a failed state. Oh no, okay. So this is the benefit of having run Kubernetes and Azure Functions. So by default, in Azure Functions, so it didn't pop the message off the queue because it couldn't start the pod previously. Fingers crossed it actually works this time. It looks like it's going to succeed. That's last words. But that event was left on the queue. Eventually it will timed out and it deploys a message queue. We'll get one of these up and running. See what happens. Let's go add some more. Yeah. So that's now spinning up a bunch of pod instances, running my Azure function to catch up and keep that queue back down to the level that it needs to be. So I'm not going to sit around watching that run. What we can go and do is we can go and have a look at our thumbnails. We should see a bunch more thumbnails in here. One running for 66 seconds. I should already create a thumbnail. We made a wire of. Nothing like debugging on the fly. Someone's suggesting the right terminology here. Alright, so it is running. It's taking a little while to get through the backlog. So by default, the host will pop a certain number of messages and deal with it on its own. I don't have to worry about mutexing or managing which message is going to which host. That's taken care of for me. So hopefully if we go back, maybe I'll just do it. Completely broken something. So that means it's still uploading the file. I may well have overloaded it, try to push the files back into the storage account. All right, let's leave that running and I'll wrap up and come back and see if it's proved for me to be a liar. So what do? We dev locally, created a container, we push that container up into Azure Container Registry, pretty easily put into like a hub. And then we deployed that image into AKS Kubernetes. So again, put it in any Kubernetes service. So what does the future look like? So the Azure functions host will be containerized, not tied to Azure. Yes, it's written by Microsoft, but it could be your serverless event-driven execution engine anywhere. It doesn't have to run inside of Azure. But what's really missing to make that a reality? So clearly, the runtime host is written by our team. It's open source. You can go and check it out on GitHub. You can make pull requests. But we don't write for every single language that's out there. There are community members that are writing Rust runtimes. There is a Golang runtime that's been written by the community as well. It's kind of been curated by some of our folks. But maybe there won't ever be a Microsoft first-party runtime host. But nothing stops you from implementing your own. Uses gRPC under the covers to do inter-process comms, so you could go away and write your own if you really wanted to. The asterisk there is that we'll probably won't give you support if you write your own, but nothing stops. Event bindings and triggers, so that's kind of the special sauce of event-driven programming, is having event bindings and triggers that you don't have to write any of the glue logic for. They're already there for you. So here I'm listening to Azure Storage Queue. I didn't have to write all the glue to go away and listen to that queue. I literally imported the namespace to use that code and then say, here's the queue I want to listen to. I don't have to do any more than that. Now, we don't have those for every permutation of likely event-driven scenario that's out there. But again, it's open source. We have a definition. We give you the ability to write your own custom extensions if you want to. So nothing stops you going away and implementing your own event-driven extensions for the functions runtime host. So again, we don't maybe write it ourselves, but nothing stops you from using it. So you might run this on-prem, in Kubernetes on-prem, and your execution engine is the functions host, but your events are actually coming out of, say, a SAN or an Oracle database or whatever it might be, and you've written the extensions to allow it to be event-aware for that native source that will down the street. And then Kata triggers. So unfortunately, with Azure Functions, we don't magically turn the functions extensions into Kata triggers for you. With the functions extensions you write yourself, they're automatically made available across all the languages that the functions host supports. So you don't have to go away and implement them in anything other than .NET Core. But if you want to use them with Kata, you've got to be able to write extensions for Kata using Go. And if you go and look on the Kata project website. Jeff Holland, who Peter talked about before, we've actually got an open issue on there at the moment. So we have a thing on Azure Cosmos DB called the change feed. I'm not sure if you've used it or not, but it's a really cool thing where you can listen to a stream of events coming out of Cosmos DB. So if you use DynamoDB and you use the what the change feed is called in DynamoDB, maybe it's called the change feed, but it's similar to that where you receive events. We can't implement that at the moment because there's no Go SDK for that particular feature of the Cosmos DB database at the moment. So there are some blockages around that, but nothing stops you going away and writing all of this. So I think for me, the story here is it's like you're not tied to Azure if you really want to use this, but if you want to start to introduce serverless as a paradigm in your business or event-driven programming, then you can use this host and you can use it anywhere. You get the benefit of using it as if you want, otherwise you can run it in Kubernetes if that's what you need. So you can go away and read Keta. I do love that PowerPoint manages to show that I clicked on that link. That's okay. That's me reading my own blog about this presentation. So everything I've shown you tonight is either on GitHub or up on my blog. You can go away and try it out yourself. See how much truth I've been talking about running Azure functions outside of Azure or not. And then finally, the dev community. So through the next sort of 6 months or so, I'm going to be at a lot of events. Maybe there's some stuff you've heard tonight or you've heard about in Azure. The dev community is a really good place to go and join. It's not sales spam because I make sure that it's not sales spam. It's actually things to events. So if we do special events where maybe we've got people like Sacha coming into town, we might use that as a way to reach out to people so they get opportunities to join and hear about that before we maybe talk about it publicly. So it's a great place to go. Or in fact, Jeff, we've got Jeff coming. We might do some invite-only stuff with Jeff. So that's pretty much my talk. Let's just quickly flip back and see whether Kubernetes and functions and all that stuff actually maybe before did its thing. And then I'm happy to take questions, happy to hang around if you've got to go. I'll be here for a while. I've got to lock up and make sure that people leave when I tell them to. So let's just go back and see what's happened. No. Alright. So broke. I'll have to go and have a look at what's happening there. Yep. So if you want to read the scale object definition, actually lives up on scale object specs. So Red Hat's doing a lot of this stuff because they want it to be supported in OpenShift. OpenShift is now certified Kubernetes runtime environment, but you can go and build your own if you want. So you'll see that's called TypeScript Go. So this is all implemented in Golang. And then they have specific details about, there's how you do min replica count, max replica count, and then some examples around supported triggers. So overseas trove storage queues it's already supported, but you can then get into RabbitMQ. So they have an example that's using native Keta without using functions, which uses RabbitMQ. I think Kafka was just one of the.
Yeah, that was actually my next question. Like, where do you define which queue are you watching for the event trigger?
Okay, and then the connection string. So if you've done Azure functions before, having a connection string and then a separate queue name would be fairly familiar to you. And using the tooling, it did that mapping for me automatically. And queue length is optional. So if I don't put 5 instead of 5, so yeah, Chris.
from those things.
So you're talking specifically about the Keta scenario?
Yeah.
So it's not great at the moment.
Yeah. So is it good, only good for offline process or good for online?
For the time being, so the Keta project is only in incubation at the moment, so it's not really ready for production use. There is, if you have a look up here, you'll see that there's a polling interval. So you can shorten that polling interval down depending on your scenario. Look, there's no magic in event-driven programming, right? It's something's listed somewhere, and that listing is usually on either a tight loop or it's a periodic poll. It's just a matter of whether you write that code or the framework writes it for you.
Because my original folder was like lambda.
Well, Azure Functions without Keta is like lambda. So you don't, here we've kind of done inception here. So we've gone Azure Functions, which is completely PaaS, which is more like cloud run. That has a much shorter startup time than this. This is really heavy duty. The scenario here is you're probably already doing Kubernetes in your organization. You want to do event-driven programming, but you don't want to tie yourself to Azure PaaS, but you want to use an independent format that allows you to run on any Kubernetes infrastructure, so you would do this. But you've got to live with that over here. You're not going to get that instantaneous, at least not at the moment. There's a lot of movements there. So ACI, Azure Container Instances, has got a very short start time, but it's got to pull the image down and then start that up. So the bigger your image, the longer that's going to be. I think my container image here is like 700 megs because of all the bits. But
Yeah, so sorry, obviously containers are bigger, so they've been, in one you cache them, but those are functions, maybe not more caching the dependencies into your functions, so they'll be faster startup times.
So I've had a bit of a play. The functions team has baseline images, so the baseline image that they use here, I think, is based off the Kathmandu release. But they do have Alpine Linux definitions as well. Now, I couldn't get those things to run, so I suspect that they are probably early stage development, but they're available because the functions team works out in the open. But Alpine Linux is, it's really bare bones. Your challenge is probably going to be how you'll get things like FFmpeg to install on Alpine, because Alpine probably doesn't have a lot of pre-built packages for it, so you're probably at that point compiling, downloading source code and compiling as part of your Docker build, which I don't know how I feel about that. Notionally, because ACI and ACR, notionally because the container registry and the Kubernetes service are in the same region, that pull time should be relatively short, and it's going over private backbone inside Azure, so it shouldn't be too long for that. But if you're doing it cross region, then you probably use something like container registry geo, which basically creates a proxy in each region you tell it to, and then we copy the container image across into that region, and then your Kubernetes instances in that region, when they pull from the container registry, they pull from the nearest instance.
Simon and Christian, I've got in terms of the workflow, say I drop a file onto Azure Blob Storage. How does that go? Do I need a Azure trigger function to put a message on the queue to trigger Keta in order to?
Good question. So at the moment, the answer to that is potentially yes. So today was a bit convoluted. I said it wasn't really a convoluted call. I did this because Azure Storage Queues is one of the supported triggers today. As soon as Azure Blob Storage becomes an available trigger, then I wouldn't have to worry about writing that message. Now, my experience is that you might want to still write that message because you might want to do other enrichments over the life of the object. That having a new file has arrived may not be the right trigger source, but once you have a native Keta trigger for blob storage, you don't have to write that message.
So I guess the question is, you envisage a future where Keta, the ecosystem of triggers for Keta is as rich as Azure Functions or any other serverless compute is today.
Yep. And there's people already working on that, right? So if you look at the open issues,
Because you mentioned Cosmos DB streaming.
yeah, so Cosmos is pretty simple. Okay.
Maybe they don't propose it. Yeah, definitely liked the chap's question up the back about latency and stuff like that. I noticed metrics were in the polling was in the seconds as opposed to sometimes with some sort of event-driven architectures you can get sub-seconds.
Yeah, so I think my experience usually with event-driven in any platform is that you will get a cold start, and generally once things are up and coming, you're not really getting that lag anymore. So here you've kind of got multiple levels to contend with. So if you were to deploy that Docker image into Azure App Service on a service plan, there's always one instance of that thing running. So as soon as that message appears, nothing's having to be rehydrated and started. Or you can use the premium plan that they announced, which deals with that even further by introducing some new scale controllers.
And just a security bone to pick with you on the container versus function side. Like you mentioned, I guess, when you're creating your container images and you're in a company that's got Thinkfire as an open source project where it can scan container images and stuff.
Yeah.
Yeah, I guess you would imagine that the containers effectively, Azure Functions would be a container image that's following some sort of queue or Kafka topic or something like that, whichever way that it's operating behind the scenes. You'd imagine that the team at Azure Functions does a much better job at making that container image secure.
Sure.
Than what maybe a 20-person dev team would be able to achieve.
Yeah. So if you take the scenario we had today, who maintains that FFP?
Sure.
How much malware is being out? What's that risk? So the scenario I'm talking about is not so much first-party Microsoft code as other binaries you might choose to leverage as part of your implementation. So the scenario for me previously has been leveraging some fairly simple binaries in a Lambda environment where I can deploy my Lambda code as a binary, and then I can execute that binary using just a process call. Who wrote that binary? How did that binary get security scanned before it was deployed into that Lambda function? Here, if we put it into a container, we can security scan that container before we deploy it, and we can at least have some confidence that the binary that we deploy doesn't have a known CVD. So that's the scenario I'm more interested in, less about Azure Functions teams opening up a wide hole in the ecosystem, because they go through pretty rigorous security scan.
Yeah, that's kind of flying the serverless flag. I was trying to sort of say that you're probably better off, putting your house on, say, the Lambda security team or the Azure Functions security team, rather than maybe the single security person that you've got in your.
I'll let you come and talk to some of our major customer security teams and see how that discussion goes for you. I mean, security's been putting in known technologies since 1973, so there's no reason for them to change to the cloud. But that's a bad joke, I'm sorry. Knowing technology. That's all right. What else that time? Just pull request, scale up GCP pops up. It's open. And so it probably hasn't been through a approval process. There is a weekly community call you can go and join if you want to contribute. But it's open. It's on Kubernetes. We can't stop people from building things for Kubernetes. One of my we use it ourselves. Yeah. Last question, maybe, if you want to grab me afterwards, come say why. No, ask just one people that just people. I have t-shirts and hoodies, by the way. Make up for you hanging around. Yes. First come, first serve. Yes, come see me. Yes, question.
Just to, I'm not sure if I understood properly, but if I'm running a Kubernetes cluster today,
yep,
I can have a service which listens to HTTP as HTTP, or I can have like a service bus listener. Basically allows me to get into the cluster and then do whatever I want to do. So this data thing is to allow different type of events.
This is to drive scale. So nothing's stopping me from having a container image that I deploy to Kubernetes today that's listening to an into a service bus. But how do I then tell Kubernetes I've got millions of messages on the service bus queue and I need to scale? Because the HPA natively and the way pods work is CPU, memory, HPQ memory.
So we have all those state features available for Kubernetes cluster.
Yeah, but so here we're driving it for events. So Kubernetes had no idea about Azure functional queues. Sorry, Azure storage queues. None. I could write the code by deploying to my pod, but then I have to have my pod tell Kubernetes, oh, I'm too busy, you need to scale, which is the wrong mode of operation. Does that make sense?
I think scaling a Kubernetes cluster. I work with Kubernetes, but I don't know if it's a proper schedule.
Yeah, that's what this is.
But I mean, let's say if it's one Kubernetes cluster, I also
There's a lot of work you can do to drive auto scaling using things like Prometheus, but then you're doing all the legwork there. You're having to build and maintain and get it wired up. Have somebody on your team who understands Prometheus and scaling in Kubernetes. Whereas with this, deploy GitHub as a dev team, I know that I'm going to use Azure storage queues, and then because I deploy my function or my header aware app into Kubernetes cluster, header has already taken care of that for me by having a scaler that understands the way the events work, and then using the control of the metrics adapter to drive the native HPA horizontal pod autoscaler capability of Kubernetes to scale based on that.
And does it run like pods in the queue system namespace, or is it like
you can define the namespace of something when you deploy it.
Oh, yeah.
So we kind of skipped over that. See what you see there.
It's not a CI. It's not a custom resource definition.
It's a custom resource definition. It's custom resource. All right, cool. Let me just flip to the last slide. If you want to look, not too fast. All the way past me. How about that? I won't actually say you want to quit. See how fast I go. There we are. There are my details. Thank you very much for hanging around. Come and see me if you want to grab something afterwards. Pete, over here.
Yeah, thank you so much, Simon Wayne. That was a fantastic presentation. As we mentioned, Serverless Day Sydney Community Conference on the 27th of August. We've basically got the person to talk to in regards to serverless functions on Azure and Kata as well. Jeff Holland, coming all the way from not Seattle, it's Redmond, isn't it?
Seattle.
Right, fair enough. So yeah, definitely have a look at that. We're on again on the 1st of August. We're going to go see the fine folks at Alibaba Cloud. We've got an Auth0 presentation, which is pretty cool. If you're ever looking to set up some authorization and authentication on your web apps, so single page web app, Auth0 is definitely a pretty cool company to take a look at and get that all sorted out. But thanks again. See you next month.